Hi viewers, this is Kuppusamy. In this lecture, we will discuss about compiler technology. First, we will see the definition of compiler. So, the compiler is the set of programs or software tool which translates the high-level programming language into lower-level programming language. So, for example, C, C++, Java compilers. When you are look at this source program is written in the editor, any one of the editor, then that is passing to the compiler. Then the compiler will check the source code line by line. In that source program, if any error is there, it will send the error message to the user. Otherwise, it will create the object code program. So that is the process of compiler. We will see in detail later lectures. Why we are studying the compiler technology? Because the computer professional knows only about high level programming language and computer hardware. High level programming language, in the sense the set of that a code is having the set of English words and also symbols, operators, etc. So every programmer knows only the known set of programming words and computer architectures. So the but some of the software professional may know the assembly programming language, that is machine level language, but every programmer does not know the machine level language. So we need the some mediator tool or interface tool to interface to connect the computer programmer, that means high level programming language and computer architecture, in the sense hardware. So that compiler is doing that work to interface the high level programming language and computer architecture. That means that high level programming language will be that is known to the computer professional is converted into lower level programming language which is understood by the computer hardware. So it is very necessary to the computer professional to understand about compilation technologies, to know about how the programming languages and computer hardwares are connecting together to convert high level programming language into lower level programming language in software engineering platform. Then this presents applications of compiler technology. So where we are using the compiler technology in practical. So compiler technology is having some set of tools. In the tools, that parser is used in the HTML language to develop the web programming languages. So parser will construct the parse tree from the set of tokens. Then that interpreters are used in JavaScript or Flash programming. Then the compiler is used to generate the any target machine code from the high level programming language. Another one application is software testing. Testing in the sense it is checking the developed computer programs or computer modules or computer software that verifies the any errors are there, and also it's satisfying the expected outcome of the software professional. So in the software testing also, which is used to convert the uh, that the developed software into machine level code. Then program optimization in the sense here it reduces the number of lines during the compilation. So there is also we are using the compiler technology to optimize the developed program. And it is also used in malicious code detection. Malicious code detection in the sense anonymous code or anonymous programs which are developing in the which are detected by the compiler technology during the compilation. Then design of computer architecture. So already we know the compiler is converting the program into computer language. That means low level language. So the compiler should be developed based on the computer hardware platform. What is the computer architecture we are following? So based on that computer architecture, that high level programming language to be converted into that respective hardware platform oriented machine language. Then hardware synthesis. So hardware synthesis here, that VHDL means very high speed integrated circuit hardware description language. Every hardware is need of hardware description language in the digital design logic. So during the computer machine language design, we need to follow this VSDL to RTL translation in the sense converting the one programming language into another one programming language. There, the compiler is used. And last application is the simulation of compilation. So here it is used to simulate the design which are written in the VSDL. So it will simulate the hardware description language to present to the user how it is working. And since that compiler is not having the interpretation, it increases the speed of compilation and program execution. Then we should know about complexity of compiler technology. So here complexity in the sense time complexity and space complexity. So here compiler is the most complex system software. This is system oriented software. So it is very much complex software tool. So when you are writing the compiler, we have to take care of complexity of the tool. So it should give the better time complexity to the software compilation and execution. So this writing the compiler is having the important exercise in software engineering field. The complexity is purely based on the mapping of your source program, that means programmer's requirement, high level language source program into that computer architecture oriented programming. So how many lines we are writing, how that what is the that memory space occupied by the identifiers and symbols in the source program, and how it is mapping into the low level programming language. Then based on that, the complexity of the program will be increased or decreased. So this compiler technology uses various algorithms and methods from the computer science domain, which translates the complex theory into practical. The compiler translates the complex theory into practical that enables the tool building. Nature of compiler algorithms. So what it is doing? So the compiler draws the results from mathematical logic, lattice theory, linear algebra, probability, so in different fields of the mathematics. Mostly computers that computer compiler is based upon the calculations or computations. So what it is doing in the sense, it checks the data type of the identifier, static analysis of the identifier, and dependence analysis of code. Dependence analysis in the sense, for example, the one class may be dependent on another class. Derived class depend on the base class. Some variable will be propagate from the assigning the value itself. So that dependence analysis will be done by compiler, and loop parallelization the in Java compiler we may see the thread concepts. So how that parallel loops will be executed and cache analysis, memory allocation. So all these things of process will be done by compiler, and some of the applications used the following algorithms in the compiler. Greedy algorithms can be used in register allocation. Register in the sense temporary storage in the computer architecture. So how, which kind of register to be allotted to which kind of identifiers. So these kind of things can be done by greedy algorithms. Heuristic search, it is this kind of algorithms can be used to scheduling the lists or arrays to the CPU. So then graph algorithms can be used in dead code elimination. Here, dead code elimination in the sense which are the code we written in the source program is not used during the execution. So that is unused code. That unused code can be eliminated by the compiler. So there we can use the graph algorithms. Again, the graph algorithms can be used in registers allocation to the program, and dynamic programming can be used in instruction selection. We are having the set of instructions in the program and also computer hardware, so it can be done by the dynamic programming algorithms. Then optimization techniques, which are used in instruction scheduling to the CPU, and finite automata theory. So this machine, finite automata machine, can be used in a lexical analyzer. That lexical analyzer is used to convert the all the lines from the source program into set of tokens. We will see in detail later. And push down automata is used in parser. Then parser, already we know from the tokens it will construct the parse tree, which checks the syntax of the every line in the program. Then fixed point algorithms, which are used in data flow analysis. So here data flow analysis in the sense how we are assigning the values or data to the identifier and how it is propagating throughout the program execution. So this kind of concepts uses the fixed point algorithms. And last one, complex data structures. That data structures are used in the compiler, that symbol tables, parse trees, data dependence graphs, which are all the different kind of data structure which are used by compiler technology. Then additional uses of scanner and parsers given here. In assembler implementation, we are using the scanner and the parser. Scanner in the sense lexical analyzer, which creates the token from set of lines in the source program. Parser construct the syntax tree or parse tree from the tokens to check the syntax of source code of its own programming language. Then which are used in online text processing and searching, then website filtering, command language interpreters, scripting language and program. We are having different languages: programming language and scripting language. Here the scripting language in the sense control, it will control the one or more applications without need of compilation. So that kind of language is called scripting language. So scripting language interpretation also uses the scanner and parser, XML parsing and document tree construction, and database query interpreters. All these domains are using the scanner and parser to construct the tokens and syntax tree respectively. And additional uses of program analysis techniques. This program analysis techniques used in converting a sequential loop to parallel loop, and also it is used to determine the concurrent access free, that programs are concurrent access free or not. And also profiling programs are used to measure the time, time and space complexity